Mathematical physics is based on very advanced pure mathematics. Pure mathematics is based on mathematical logic and axiomatic set theory. Thousands of theorems are needed to express the laws of mathematical physics. The Metamath language enables mathematicians to precisely express axioms, theorems, and proofs. The Metamath tools automatically verify proofs for correctness and help mathematicians create new proofs. The Metamath database contains the proofs of over 27,000 theorems. We will focus on studying and proving the subset of those theorems that are applicable to mathematical physics. Figuring out how to prove a theorem is a lot like figuring out the best sequence of moves in a chess position. We will approach proving theorems in the same way that chess tacticians approach calculating their move sequences. We will become expert logic tacticians, specializing in the unique axioms of the Metamath formal system. In this first video post, we will start by creating a Metamath database file from scratch using a text editor. Next, we'll use the Metamath command line program to check the file for errors. Then we will load the file and explore its contents using the Metamath LAMP Proof Assistant web app. Next, we will use the LAMP Proof Assistant to create our first proof. Lastly, we will update the database file with the encoded proof text. Let's get started by opening a plain text editor and entering our Metamath language statements. We'll declare the constant symbols that we will use to express our axioms and theorems. Next, we'll declare our variable symbols and then their types. Now we'll add a couple of axioms that specify valid formula forms. Axiom statements also have unique labels. Next come our three propositional logic axioms and then the standard modus ponens deduction rule, which is expressed as an axiom in Metamath and has two hypotheses. Save the file as mytheorems.mm. Now we will run the Metamath command line program and read in the saved database file to check it for errors. It looks like we have an error on line 14. Let's go back to the database file, correct the mistake and save the changes. Now we'll go back to the command line program, clear the buffer, and reread the file. Now we have a valid Metamath database file that contains Metamath statements that will enable us to start proving propositional logic theorems. Let's navigate to the Metamath LAMP Proof Assistant web app and load the database file there. Click the Explorer tab to view the file contents. The first theorem that we will prove is labeled MP2 in the standard Metamath set theory database. It basically lets us deduce that chi is a theorem when phi, psi, and phi implies psi implies chi are already theorems. Here is the MP2 theorem page from the Metamath website. The Greek letters correspond to the first three formula variables in our database file. The hypotheses are the formulas that we assume are already theorems. In the proof, we first deduce the theorem in line 4 by using modus ponens on the formulas in lines 2 and 3. Next, we deduce the theorem on line 5 by using modus ponens on the formulas in lines 1 and 4. This theorem is referenced by dozens of other theorems. Let's return to the Proof Assistant Editor tab and create our proof. First, we will enter our goal theorem. Click the plus icon and enter chi, and then either click the save icon or press the return key. Next, long-click the QED text and enter the theorem name, MP2. Next, we'll enter the three hypotheses. For each one, long-click the P to change the type to hypothesis and long-click the label to change it to a number. Now create a new step and enter psi implies chi and press enter. The Proof Assistant will automatically complete the proof and display a dialog box. Click the Copy button to copy the completed proof text to the clipboard and then click the Close button. The proof assistant automatically figured out that the new step was justified by using modus ponens on the first and third lines, and that the goal theorem was justified by using modus ponens on the second and fourth lines. Now update the database file by pasting the copied proof text at the bottom of the file and saving the changes. Congratulations! In this video, we created a Metamath database file and used the Metamath command line program to check it for errors. Then we loaded the file into the Metamath LAMP proof assistant and used the proof assistant to create our first proof. Lastly, we updated the database file with the encoded proof text. In the next video, we will begin the very long process of systematically studying the most widely used propositional logic theorems and their proofs.